Hi guys, welcome back to the channel. Today we are going to see how to send and receive JSON data into Azure EventHub. This is a very interesting project because you can send and receive real-time data in Azure using Azure EventHub or IoT Hub. There are many things you can do when you receive real-time data in terms of analytics. You can capture, but from a technical point of view, you can capture the data and save it into the data lake, or you can use Spark streaming and keep receiving real-time data. In my last job, we used Kafka and CDC, which stands for Capture Data Change, because we wanted to migrate all the tables from the on-prem database to Azure SQL Server, and then keep streaming all the changes as it comes in the database. And when we were almost done with the project, an engineer from another team made a comment and he said, "Why don't you use Azure EventHub instead of Kafka?" And we were like, "Oh, that's a pretty good idea. We never thought about this." So now in this video, we are going to implement a pipeline which sends data from our local machine to the EventHub, capture the data in Avro format and save them directly into the data lake. But we are also going to extend this pipeline using Spark streaming in Databricks and read the data as it comes to Azure EventHub, and then write the data into the data lake. Having said that, let's begin by creating an event hub. On the search bar, type event hub, and you will see this icon here of event hubs. I have already created an event hub, but I will show you how to create a new one. You click on create, subscription, you select the resource group, the namespace, so the test event hub, that's the namespace name. You pick the location, the pricing tier. Be careful here if you want to capture the events and save them directly into the data lake. You have to use at least the standard pricing tier, right? If you use the basic one, you won't have this opportunity. Yeah, I know what can you do? Azure, the Microsoft wants to make money, right? Anyway, you have to select the standard pricing tier, then go to the next one, advanced. Make sure you have enabled the local authentication. You will need that. And you keep everything as it is, the same connectivity method, public access, tags, we don't need tags, review and create. I'm not going to create a new one because I have one already, but when your Event Hub namespace has been created, you will see this one and you will click on it, and this is the screen that will appear. Now, again, the first thing you have to check that the local authentication has been enabled. You have the standard pricing tier. Now, what we need to do here is to create a shared access policy. That's already been done when you create the Event Hub namespace. You will get this root mount shared access key, and it by default it has all the privileges, to send and listen to events. However, we need to create an Event Hub instance. So this is the Event Hub namespace. It's not the same as Event Hub instance. This is the Event Hub instance. You have to click on Event Hub, and here just type a name, use the partition count you want, cleanup policy, delete, okay, that's fine. And then you click on next, capture, you click on. Again, you need to have the standard pricing tier if you want to capture data, time window, etc., etc. Azure storage container, you select the container. I selected this one, let's say this one, it doesn't matter. And by default, this is the path that EventHub saves the data into the data lake. So it's the namespace, EventHub, partition ID, year, month, day, hour, minute. It would be like this stored in the data lake. So you see the path, it's a big path, but this is how EventHub partitions the data. And actually it's pretty good when you have to query those data. You can query by partition, by year, by month, by day. It would be a much easier and faster query to run. And if you click review and create, I have already created one, so I'm not going to create it again. But let's go back to Event Hubs. And here you will see that would be your Event Hub, right? And you will have all this information here. What you need to do here is to create a shared access policy. You click shared access policy on the left panel. You click add. You just provide the policy name, send or listen or manage, that combines both send and listen, and then create. Now, why do we need to create a shared access policy? Because we need the connection string. So this connection string here, the for connection string dash primary key. If you copy that, that would give you this connection string. And we are going to use this connection string in our Python script in order to connect to EventHub and be able to send the data we want, right? Now that we have created the shared access policy, the EventHub instance, and the EventHub namespace, initially, of course, now we have to use this connection string and send the data in the JSON data we have into EventHub. And we are going to see the EventHub here. You are going to see a spike because that we are going to receive data. So when we receive data, you will see a spike here and the messages and all the stuff for the last hour, for the last 6 hours, for the last 12 hours. By the way, there is a consumer group created by default. When you create an Event Hub, it creates a default consumer group. Consumer groups are like the consumer we have in Kafka, so we read the data that we receive from the Event Hub. This is the reason that we have consumer groups. But now let's switch to our Python code and see how we can send the JSON data into the Event Hub. This is the JSON that we are going to send to EventHub. We have an ID drink. This is an integer. This is a string name, the drink name, which is cocktail, and the date modified, and this is a date, right? And so we are going to read this JSON here and send this JSON to Azure EventHub. We can do this by using this script that uses all the async library, Azure EventHub library, and here I use JSON to read the JSON, but these are the libraries that we want, Azure EventHub and async. You will find this script on Azure documentation. It's not my script. You will find it on the documentation. It's just Google it. It's a very simple script. And essentially what we are doing here, we are using async, okay, to send messages asynchronously to EventHub. But the main thing here is that we create a producer to send messages to the EventHub. And we have to specify the connection string to our EventHub namespace. You can do this by using EventHub producer client from connection string, and here you are going to provide the connection string, which is the one I showed you when you create the shared access policy. You copy this connection string and you paste it here, and then for EventHub name you provide the name of the EventHub instance, not of the EventHub namespace, because initially when the first time I tried the script, I used the EventHub namespace and it didn't work. And I was like, why it's not working? It's so simple. And the thing is you need to provide the name of the EventHub instance. And then the producer, you create a batch here, we load a JSON file, and here we pass to the event data this string, it accepts string only, and the JSON. And we add this event data into the batch, and the producer sends the batch and the data. It's pretty easy. 3 lines of code. You can find it on the documentation, and this is how you send data, right? It's pretty cool, but it's quite nifty that you can do it so easily. Of course, this is just an example. In real life, you will have to send more complicated JSON and other files, right? But here, that's how we send batches of data into Azure EventHub. Very simple. I'm going to save and run the script, and that will send data to Azure EventHub. So if we click run, right, now let's switch back to Azure EventHub, and I will show you, you will see the spike. We are on Azure EventHub namespace, and you see the spike here. That means we receive messages and data. That's good, right? Because that's what we wanted. Now, if you click on Event Hubs, and you go to your EventHub instance, again, you will see a spike under requests. That means you receive data, and you can click on the analytics here and stuff. We don't care about this right now, but what you can do here, you remember that when we created Azure EventHub instance, we configure it to capture the events, right, by using this configuration. Now here, when you click on capture on, and we can use Avro or Parquet or Datalake. I used Avro. It doesn't really matter right now because it is just an example. Azure storage account and our container test3, and this is the file format that you will see in our data lake, the data. Let's go to the data lake, and this is our containers, and we specified container 3. You will see the Apple Event Hub. This is the file that was created by Event Hub when we receive data, and you will see here it splits the data as we specified in the capture event window, right? And that's why we have so many folders. Now the data is in Avro format. You see, we receive data and we capture this data and save it into the data lake with very, very minimal effort, I would say. You just configure EventHub to capture the data and save it into the data lake. This is very, very simple. Instead of using, Kafka or anything else, you can use EventHub to send real-time data, and not only real-time data, also batches and all this kind of stuff. It is very, very, very useful. Now, if we go, can we see the data? Here it's in Avro format. You cannot, we need to go into Databricks and read this and query the data lake to see the results from this Avro format. In Databricks, now we are going to read the data to query the data lake and see what we got from the Event Hub. The first thing I do here is to import this libraries, PySpark.sql.types for the types, PySpark types, because we are going to define a schema for the data we receive, and from SQL functions I import everything just because I'm too lazy to specify what I'm importing, although you have to do it in production. You don't want to import everything. And here the code that I commented out is to actually configure Databricks to have access to Azure Key Vault and be able to query the data lake using our service principal. I went over it in a previous video if you want to check it out, but for now I'm just telling you that I have configured Databricks using service principal to point and created a mount point that refers to the data lake using this code here. This JSON schema, here we have to define the schema of the data that we receive from Azure EventHub. I will show you how we receive the data from EventHub. The first thing we need to do is to read the data using spark.read.format, Avro format, load, and we load all the data in the data lake that ends with this Avro extension. And if we run this and display the data frame, you will see we are receiving data but in a different format, not how we send it. We are not going only to see the data that we send, the JSON data that we send, we will see extra columns. And you will see what I'm talking about right now. We have the sequence number, the offset number, the enqueue time UTC, system properties, and body. Now, this body here contains the data that we sent. This is for, let's say, offset sequence number. This is how you specify the place that if you want to, let's say, start streaming from a specific offset onwards and stuff, this is how you can use this information here, these columns. But for now, let's assume that we only need the data that is in the body column. What we can do here is actually use this df dot with column body, which is the column here, the column name here, df body the column name dot cast as string, because as you can see it's encrypted, and select body, we select only the body column, right? You have to cast it as string to get our data in the original format that we sent it. So if let's remove this and let's run this again, and now we are going to see the data that we sent initially as we send it from Python, right? And it will display a data frame with the JSON files here. As you can see, I run the script multiple times, that's why we have multiple records here. But you can see the body now contains the JSON string that we sent. Perfect. But you also can do this by defining the schema. So column ID string would be, let's say for now I'm using string type, or you can use integer type or date type, etc., etc. There is check the PySpark data types if you want. So here, this is how we define the schema, and this is how what we do here, this is how we pass the schema. Now, instead of using this one, we can use df dot with column body, we select the body column here, and from JSON, because it's a JSON, that column is a JSON string, from JSON we cast a string, and we also pass the schema, and it will provide the data types into the columns, that the data types we have provided into the columns, right? So now we also have the data types we want. And again, the same thing, it will display the whole, but this time it's going to display the whole data frame, not only the body column with the content. It's going to display all the columns. However, we can select, you will see now. Yeah, it's not that fast, but anyway, here we got the sequence number, the offset, system properties, and body, and you will see the content, right? And you will see ID drink, cocktail, date modified, etc., etc. Now, how can we select this ID drink here, or the drink name, or the date modified? We can do this by using df, the data frame, the last data frame, dot select column, we specify the column here, body, which is this column, dot id drink, and this will give us the nested column. So that's how you get nested columns. You use column name dot the attribute, the nested attribute name, and we have 3 columns. So if we display the last data frame, you will see now we will have a data frame with 3 columns, and this is, I imagine that's what we want most of the time, to have a proper data frame with the nested data that we provided in our Python script to have it on Azure. And that's what we did here. As you can see, it's pretty easy to configure it. It's very easy. You have a data frame with the data we sent from our local machine. This is perfect. You see how you transfer data, you migrate data. It's so easy to do that using EventHub. Plus, you can also save the data, you capture the events, and you save the data straight to the data lake. And you get the data from, in Databricks. You create a data lake, you get the data, everything is perfect, everything works perfect. Okay, that's one way. Now we are going to extend the pipeline to actually use Spark streaming to stream data from EventHub as the data comes. Before we start using Spark streaming, we need to install the correct version of the Azure EventHub Spark library. The reason I'm saying this is because if we use a version of the library that does not match the version of the cluster, we are going to get many errors, which would be very difficult to figure out when in fact we didn't do anything wrong. It was just a version mismatch. I will provide you this, the library and the cluster I use, the versions that I used. So here under shared or wherever you want, you click right click, create library, and under Maven you provide the coordinates. This is the coordinates, and then you click create, and this will create a library. I'm not going to do that because I have already done that. Under workspace you will see I have this library. It will install the library here, and we are going to click the library here and install to the cluster. Now my cluster is version 9.1 with Apache Spark 3.1.2 and Scala to 12, right? So this is my version, and it's going to work if you use exactly the same versions I used, but if you change the versions, be careful because probably you will get an error. So back to our workspace, I have created, let's say you have installed the EventHub Spark library to the cluster. Now let's create a second Python script. Here I have imported the typical PySpark types and functions. We need to provide the connection string again. This is the connection string. As I mentioned before, you can find it on EventHub. Then you click EventHub's instances. You click on the instance. You click on the shared access policy. Click on the shared access policy and copy the connection string here and paste it here. Then you need to actually encrypt the connection string, just because this is the library, the version of this library that we are using right now, the EventHub Spark, you need to encrypt the connection string. Consumer group is the default consumer group. Remember, here I haven't created any consumer group. By default, we have this default consumer group here. We provide the JSON schema, and we start streaming the data from event hubs. So we can do this by using spark.readstream.format event hubs options, the configuration here that we provided here, and .load. Again, we can use df with column body and we cast it as string, but we can again do it like before and we pass the parameters. We pass the JSON schema. I mean, we cast the body column as string, we pass the JSON schema, and that's how you pass the schema, and you select the 3 columns that we want, and we get the final data frame. So here, let's say if I run this now, it's going to start streaming from no defined. I guess I am missing something. As f dot, oh boy, call where, come on, yeah, that's because remember I've imported everything from the SQL functions as f, so I have to specify now f dot from JSON. Otherwise I should have done, you know, from JSON like that. But anyway, so it starts streaming data. If I run, I'm going to run the Python query in the background a couple of times, and you will notice that a spike here, right? Exactly. This is a spike here, and that's because we send data from our local machine, the Event Hub, receive this data, and we receive this data and we start streaming. And now it continues streaming. So let me run the script again. You will see a few more records because I run it a couple of times more, and you will see here now a new spike, right? And call record 3, and you will notice at some point another spike, and you will have 4 records. Anyway, so this is how, right, the 4th record here. That's how you start streaming data. What you can also do is here is you can do this one. So you can, right, if you type df.writestream.format in JSON format mode append, you provide a checkpoint location, which is in our here under containers in our Datalake Apple EventHub. You will see here that this is how we save data. Under output, you will see these JSON files here. Let me do that again. Let me remove this folder. And if we go back to Azure EventHub, you will see under in the data lake under test3, we specify a folder name, output, and this checkpoint folder, and we place, you know, all the records that we received from EventHub. We stream the records and we write the output, the data we receive in the data lake using this write stream command. So we have started the started streaming. So if I run again the Python script to send the JSON data, You could see a spike again. Yep, that's perfect. And here, if we go back to in our data lake, if we refresh, you will see the output here and the JSON data that we sent from our local machine. The checkpoint events is when, let's say, something happens with our connection, something breaks the pipeline. Then when we start streaming again, if we have specified this checkpoint, then we will start streaming from the point that that it failed, right? We will pick it up where it failed and we'll start streaming from that point onwards. We displayed two ways of using EventHub to receive and store data. I would say Azure EventHub is quite useful for many operations. You can receive real-time data from IoT devices. You can migrate small tables and capture the changes, the updates, the deletions, etc. etc. Overall, I would say EventHub along with Databricks is one of my favorite Azure resources. The code can be found online, but I will upload it on GitHub too, so you won't waste time searching for it. If you like the video, please click the like button and subscribe to the channel. Thank you.